Can you be able to solve these hybrid parameters? Okay, we have to find h₁₁ and h₁₂. So this question is very simple and interesting. Okay, now before you can be able to solve this question, I want to draw your mind to our equivalent word circuit. Okay, now let me draw your mind to our equivalent circuit of this our h₁₁. Okay, then we have our h₁₂. Then from there we have our what? h₂₂. Then we have our output. This is our output. This is our V2. Current from here is our I2. This is our h₂₂. This is our h₂₁. So this is our input. This is our ground. Then this is our V1. So V1, this is current 1, which is I1. Here is our V2. Now look at what I'm going to do. Observe something carefully, okay? Now what is flowing here is I2. Flowing here is I2. Now here I have h₁₂. h₁₂ simply means that these two you are seeing, this one is in this first portal, which is this is 2-port network. Okay, now this h1 you are seeing is for this port network. This 2 means that this portal is sharing a voltage with this portal. So yes, it's V2. Now observe this again. Yes, h₂₁. This h2 simply means that this is the second portal, but this one means that it's sharing the current with this other portal. So yes, I1. So using our KV on this is Kirchhoff's voltage law, which states that the algebraic sum of voltages across the algebraic sum of all the voltage across a loop is equals to what? Is equals to 0. That means by using our KV on means that V1 is equals to h₁₁ multiplied by I1 plus h₁₂ V2. You can call this equation 1. And from here, our I2 is equals to a V1 equals to what? h₂₁ I1 plus h₂₂ V2, which is equation what? 2. Now we are asked to find h₁₁ and h₁₂. So for here to have h₁₁, which is what? h₁₁ simply means open circuit input impedance, right? So this is open circuit input impedance. It means our V2 is 0. So that means that h₁₁ is equals to what? V1 over V2 I1, where our V2 is short circuit. So this is what? This is short circuit what? Short circuit input impedance. Okay, then what about our h₁₂? Our h₁₂ will be what? h₁₂ equals to what? Making I subject will be what? V1 over V2, where our I1 is equals to 0. This is called what? Open circuit. Because when current is 0, it's open circuit. But when voltage is 0, it's short circuit. Okay, so when V1 is equals to 0, it's called open circuit reverse voltage gain ratio. Why is it called reverse voltage gain? It's called reverse voltage gain because this is the reverse of a voltage gain. Because voltage gain is equal to V2 over V1. So when you're having the reverse, it's called what? Reverse voltage gains what? Ratio. So you are defined this. Since you are defined this, you can solve this question. So let me remove this from here quickly. Okay. Let me check my mic. My mic is on. Okay. Beautiful. It's very important to check it. So this equivalent circuit of two-port network. I've determined the equivalent equation. Okay. And we are determining this. So I can remove this from here quickly and solve for our equation. Now, this is 1. This is 2. Now take note that this one, h₁₁, is equals to V1 over I1, where our V2 is equals to 0. This is called what? This is called short circuit. Short circuit input what? Impedance. Okay. Then 2 for h₁₂ is equals to V1 over V2, where our I1 is equals to 0 is called what? Open circuit. Because when current is 0, is open circuit. reverse reverse voltage gain what? Gain ratio. Wow, that's amazing. Okay, now since we have determined this, we can solve this question now. So this is pure what? Resistance. Okay, our h₁₁ is purely our resistance in this, is purely impedance in this circuit. So what are we going to do so we can find this? Remember that I say V2 is 0, so we have to draw the circuit back. So let me remove this from here quickly. Let me bring this to say find h₁₁, comma h₁₂, right? So let me remove this from here. So if this is figure 1.1, this figure is figure 1.1. So let's see another figure for this to solve for this. We'll now draw another figure in this form. This figure 1.2. This was 8 ohms, this was 10 ohms, right? Sorry. This was 10 ohms. This was 8 ohms. So V2 is 0. So this is the interpretation of this. So V2 is, so let's find our h₁₁. So our h₁₁ will be what? Is purely resistant open input impedance. So what is flowing here is our current I1, right? So by using Kirchhoff's voltage law, we see that V1, you can see that we are looking for, if you can find V1 and I1, we are getting this, you can getting h₁₁. So V1 is equals to 10 I1, okay? Then it will be a V, and look at zip, a V, and look at V1, because current follow only one direction because it did not like too much load. So the current one will flow view to the ground, to the negative side. So it will only flow through this 10 resistor. But imagine that there was no resistor here. It will only flow through this. But since there's only one resistor here, which is resistor, it means that all this, the current that is going to this direction is minus I2. Okay. Now this I1 will flow through this 10 ohms and go to ground. Okay. It will not flow through here. If you follow any, it don't like, current don't like too much load. Anywhere they see that there's a space, you just flow through. So that current I1 will flow through this 10 ohms. So this is just 10I1. So what you are going to do, you're looking for V1 over I1. So you have to divide here by I1 and divide here by I1. So the I1 cancel out. So you see that V1 over I1 is equals to 10 ohms. So it means our h₁₁ is equals to 10 ohms. Wow, that's amazing. I know most people will say, why is it that the current did not flow through this? Current did not like too much load. How current is happening when there's no load, it's only flowing. So it's only flow through the part that see that there's not too much load. But when there's too much load, you are suffering the current, right? Even you say you're washing, you don't like too much work. So you only work the one you know that is small. So the same way current operates, current will just flow through this 10 ohms. Few, you know, consider that there's another resistor here, okay, and go straight to the ground or to the negative side. So that is it. So you have answered this question, right? That's amazing. Now let's answer the second one, which is what? Which is our h₁₂. Our h₁₂ is the open circuit. This is short circuit, right? This is open circuit reverse voltage gain ratio, right? So let's find it quickly. So let me write it here that h₁₂ is equals to V1 over V2, where our I1 is equals to 0. So I'm going to draw the circuit here. Let me remove this from here. Okay. So that means I want to draw this here plus this. Okay. Wow. V1. This is I1. Remember that I1 is equal to 0, right? For I1, so there's no current flowing through here. There's no current because I1 is 0. There's no current here. Then our V2, and here is our I2. Okay. Wow, that's amazing. Now this is circuit. So this is figure 1.3. Now observe from this circuit, because we're going to determine our V1. If you can know V1 and V2, we're going to our reverse voltage gain ratio. Okay. Now what are we going to do here? From our output, we see that our V2 is equals to, this is our 8 ohms, right? This is our 8 ohms. Because 8, because the current will flow through here, so it become h₁₂. Okay, just that our V2 is equal to h₁₂. You can call this equation 1, right? Now observe from here. If here is V1 and there's no current flowing, take note that this V1 is also here. It's also operating here because there's no current, but the voltage is still here at this junction. So if the voltage is at this junction, it also means our V1 is equals to 8 what? 8 8 8I2. You see? So for us to determine V1 over V2, it means that V1 over V2 is equals to 8I2 over 8I2, which is equals to what? 1. Okay? Now, take note that this is what unitless, it do not have any unit. Also note that current gain do not have any what? Unit. Okay? Anything have to do with gain don't have units. So the reverse voltage gain do not have unit, is dimensionless. So it means that this do not have unit, so it's unitless. You can write it as unitless. Unit what? Unitless. Okay, so you can see that we are determining this. Our h₁₁ have unit because it's in ohms, it's purely resistance. So it was open short circuit open input impedance, which is our h₁₁ is equals to what? 10 ohms, and our this is our h₁₂ is equals to reverse voltage gain ratio equals to what? 1, and this is unitless, and this is a beautiful solution to this particular question. So thank you so much for watching this video. Please, if today is your first time watching us on this channel, this is Sagas Online Maths. We based on mathematics and what engineering what question, okay? And this is one of the engineering question in level what 300 about hybrid what parameters, okay? So if you really find it very interesting, don't hesitate, do well to like, comment, and make sure you share it to loved ones so that others will learn from it. And if you're not subscribed, consider to subscribe to this channel so anytime there are exciting videos, you'll notify. So thank you so much and God bless you. Bye bye.